you think the world is made of solid matter, right? Nikola Tesla knew better. He knew that if you look closely enough, everything, from the chair you sit on to the stars above, is simply a collection of atoms vibrating at a specific frequency. To Tesla, the universe wasn't a collection of things. It was a symphony of numbers. He didn't need blueprints or pens. He built entire cities of light inside the total darkness of his mind, letting imaginary motors run for weeks to see which parts would wear down first. He claimed he could split the Earth in two like an apple if he found the right vibration. Tonight we look past the copper coils and the high voltage arcs to ask the question that drove genius Nikola Tesla to the edge of madness. What is vibration? This is Sleep Entangled. Welcome back. Chapter 1. The Boy Who Saw Lightning. To understand Nikola Tesla, you must first understand that to him, the universe was not a collection of objects but a vast, shimmering ocean of frequencies. Most of us see a physical world of wood, steel, and stone. Tesla saw a world of waves. He was a man governed by a numerical ritual that baffled his contemporaries. He would not stay in a hotel room unless its number was divisible by 3. He would walk around a building 3 times before entering its doors. He wiped his dining table with precisely 18 napkins, 3 times 6. To the casual observer, these were the compulsions of a man losing his grip on reality. But to Tesla, these weren't quirks, they were a synchronization. He believed that the numbers 3, 6, and 9 held the key to the universe. He was trying to tune his own biology to the fundamental resonance of the Earth itself. Born during a midnight lightning storm in 1856, Tesla's life began with a flash of light, a literal spark that seemed to ignite a lifelong obsession. While other children played, young Nikola was fascinated by the static electricity he felt when stroking his cat's back. He wondered, is the whole world just a giant cat being stroked by the hands of the gods? As he grew, his mind developed a capability that bordered on the supernatural. He possessed what we might call a 3D mental laboratory. He didn't need to build prototypes out of copper and iron to see if they worked. He would build them in the silent, dark spaces of his mind. He would set these imaginary machines in motion and let them run for weeks. When he returned to them in his mind's eye, he could see exactly where the bearings had worn down, or where the vibration was off-center. By the time he arrived in New York with nothing but 4 cents in his pocket and a book of poetry, he already carried the blueprints for the modern world inside his head. He didn't come to invent a better light bulb. He came to harvest the very vibration of the planet. He understood that magnetism wasn't just a force that pulled at needles, it was a language. If he could create a magnetic field that rotated, he could create a fountain of energy that never ran dry. This was the birth of the polyphase system, the heartbeat of our modern electrical grid. As you breathe in the stillness of this moment, try to imagine the world as Tesla did, not as a silent, still place, but as a humming, vibrating web of energy. Every atom in your body, every star in the sky, and every wire in your walls is part of this same great vibration. Tesla didn't just invent the future, he felt it coming. And he knew that to master the lightning, he first had to understand the secret math of the shadows. Tesla knew that to master the lightning, he first had to understand the secret math of the shadows. But before he was the master of lightning, he was a boy in a small village called Smiljan, born in the eye of a storm. His mother, Juka Mandic, was in labour in a small village called Smiljan, in what is now Croatia but was then part of the Austrian Empire. Outside, the sky cracked with electricity. Thunder shook the wooden house. Lightning turned night into day. The midwife, frightened by the storm's fury, told Zhuka that the child would be a child of darkness, born under such violent omens. But Zhuka replied calmly, "No, he will be a child of light." She had no idea how prophetic those words would be. Tesla's father, Milutin, was an Orthodox priest, educated, thoughtful, but stern. He wanted Nikola to follow him into the priesthood, but young Tesla had other ideas. From his earliest memories he was drawn not to scripture, but to nature's invisible forces. He would lie awake at night watching the ceiling. In the darkness, brilliant flashes of light would appear before his eyes, spontaneous visions, hallucinatory fireworks that no one else could see. Sometimes they were blinding. Sometimes they showed him images, places he'd never been, machines that didn't exist, entire scenes playing out like a private theatre. At first his family thought he was ill, but Tesla learned to control these visions, to summon them at will. When he closed his eyes he could conjure anything, a landscape, a cathedral, a running stream, and it would appear before him, vivid and real, as solid as the physical world. He later wrote, "I could visualize with the greatest facility. I needed no models, drawings, or experiments. I could picture them all as real in my mind." This wasn't metaphor. Tesla could literally see his thoughts. In school, his teachers were astonished by his ability to perform complex calculations mentally, not by thinking through the steps, but by watching the numbers arrange themselves in the air in front of him. He could multiply 3-digit numbers in his head faster than his classmates could write them down. But this gift came with a curse. Tesla suffered from what he called an affliction, overwhelming sensitivity to stimuli. A fly landing on a table sounded like a thunderclap. Sunlight felt like knives. The ticking of a watch 3 rooms away would keep him awake. His nervous system was tuned to a frequency the rest of the world couldn't perceive. When he was 5, he tried to fly. He'd seen birds gliding effortlessly through the air and reasoned that if he flapped an umbrella fast enough, he too could take flight. He climbed to the roof of a barn, opened the umbrella and jumped. He woke up in bed, bruised and battered, his mother tending to him. But he wasn't discouraged. He'd learned something. Human flight required more than mimicry. It required understanding the invisible forces at work: air pressure, lift, weight. The world operated on principles that could be discovered, harnessed, bent to human will. At age 7, he had a revelation while playing near a water wheel. He watched the water turn the wheel and thought, what if you could capture this rotational energy and use it to power machines far away? What if energy could flow like water, transmitted across distances, made available to anyone who needed it? This idea, energy as a flowing invisible river, would obsess him for the rest of his life. But tragedy struck when Tesla was still young. His older brother Dane died in a riding accident. Dane has been the golden child, brilliant, charismatic, destined for greatness. Nikola adored him. After Dane's death, Tesla withdrew into his inner world. The visions intensified. He would see his dead brother walking beside him, speaking to him, just as real as the living. The line between imagination and reality blurred. His father, grieving and stern, pushed Nikola harder toward the priesthood, but Nikola resisted. He devoured books on science and engineering. He read Voltaire, Descartes, and everything he could find on electricity and magnetism. When he was 17, he contracted cholera and nearly died. Bedridden for months, wasting away, he made his father a promise. If he survived, he would become an engineer, not a priest. His father, seeing his son at death's door, finally relented. "You will go to the finest technical school," he said. You will become a great engineer." Tesla recovered, and he kept his promise. In 1875, he enrolled at the Austrian Polytechnic in Graz, one of the most prestigious technical schools in Europe. There, he encountered something that would change his life: a Gram dynamo, a machine that could generate direct current electricity. His professor demonstrated it, and Tesla immediately saw its flaw. The dynamo used a commutator, a mechanical switch that reversed the current direction to keep the motor turning smoothly. But this created sparks, heat, inefficiency. Tesla raised his hand and suggested, "What if we eliminate the commutator entirely? What if the current alternates naturally?" His professor scoffed. "Mr. Tesla, this is impossible. You're describing a perpetual motion machine. It violates the laws of physics." The class laughed. But Tesla didn't forget. Deep in his mind, in the mental laboratory where he built his visions, he began designing a motor that would prove his professor wrong. He didn't know it yet, but that moment, that flash of insight in a dusty classroom, would eventually power the entire modern world. So as you settle into this story, imagine young Tesla, brilliant, sensitive, haunted by visions, laughed at by his professors, a boy who saw lightning the night he was born and decided to spend his life catching it. Chapter 2. The Mental Laboratory. Tesla's greatest inventions were never built in a workshop. They were perfected in his mind. Most inventors sketch. They build prototypes. They test, fail, adjust, and try again. This is the scientific method, iterative, empirical, grounded in physical experimentation. Tesla worked differently. When an idea came to him, often in a flash of insight so sudden it felt like a seizure, he would immediately visualize the entire machine. Not a rough sketch, not a conceptual diagram, a complete three-dimensional, fully functional device rotating before his eyes in perfect detail. He would examine it from every angle, spin it, zoom in on individual components, watch how the parts move together, and then, and this is the remarkable part, he would let it run for weeks. In his imagination, the motor would spin, the gears would turn, the bearings would wear. Tesla would return to his mental workshop days later, stop the machine, and inspect it for damage. He would see which parts had worn down, which needed reinforcement, which needed redesigning. Only after he had perfected the machine in his mind, after it had run flawlessly in his imagination for weeks or months, would he build a physical prototype. And when he did, it worked. The first time. Every time. He later wrote, "Invariably my device works as I conceived it should. In 20 years there has not been a single exception." This wasn't hyperbole. Tesla's mental precision was so extraordinary that his physical prototypes rarely needed modification. He had already tested them thousands of times in the laboratory of his mind. Let's think about how impossible this sounds. Most of us can barely hold an image in our mind for a few seconds. Close your eyes and try to picture a complex machine, a clock, an engine, anything with moving parts. Can you see every gear? Can you rotate it in 3 dimensions? Can you run it and predict which parts will fail? Tesla could. And not just simple machines, entire electrical systems, motors with dozens of components, rotating magnetic fields, high-frequency transformers, wireless transmission towers. How? Modern neuroscience offers some clues. Tesla likely had an extreme form of eidetic imagery, sometimes called photographic memory, though that term is misleading. It's not about remembering images perfectly, it's about constructing them. His visual cortex was hyperactive. perhaps overconnected. When he thought about a motor, the same neural circuits activated as if he were looking at a real motor. To his brain, there was no difference between imagining and seeing. This gave him an incredible advantage. While other inventors were limited by the materials they had, the tools they could afford, the workshops they could access, Tesla had infinite resources in his mind. He could build anything, test anything, refine anything, instantly, perfectly for free, but it also tormented him. The visions came unbidden. He couldn't turn them off. Sometimes, when he was tired or stressed, the images would flood his mind uncontrollably. Bright, overwhelming, relentless. He would see entire cities of light, power stations, transmission towers, inventions that wouldn't exist for decades, all demanding his attention at once. He described it as a mental disease, a blessing and a curse. To cope, he developed rigorous mental discipline. He would force himself to focus on one invention at a time, building it methodically, running it to completion before moving to the next. This became a kind of meditation for him, a way to channel the chaos into something productive, and it worked. By the time he was in his mid-20s, Tesla had perfected the design for an alternating current motor entirely in his mind. The breakthrough came in 1882 in Budapest, where he was working for a telegraph company. He was walking through a city park at sunset with a friend reciting poetry, Goethe's Faust, his favourite. The glow retreats, done is the day of toil. It yonder hastes, new fields of life exploring. And suddenly mid-verse he stopped. His friend looked at him, alarmed. Tesla's eyes had gone wide. He was staring at nothing, frozen in place. Then, moving slowly, he picked up a stick and began drawing in the dirt. A circle, lines radiating outward, curves representing magnetic fields. "Watch me," he said to his friend, "watch me reverse it." His friend had no idea what he was talking about, but Tesla did. In that moment, the solution to the alternating current motor had appeared in his mind, fully formed. He saw it, a rotating magnetic field, not created by a commutator mechanically switching the current direction, but by the current naturally alternating. Two or more coils energized by out-of-phase AC currents would create a magnetic field that rotated on its own. The rotor didn't need brushes or commutators. It would just spin, smoothly, efficiently, indefinitely. He built the motor in his mind right there in the park. He tested it. He ran it. It worked perfectly. Over the next few months, he refined it mentally, designing not just a motor but an entire system. Generators, transformers, transmission lines. A complete alternating current power system that could deliver electricity across vast distances with minimal loss. By the time he arrived in America in 1884, Tesla had already revolutionized electrical engineering. He just hadn't told anyone yet. He arrived in New York with 4 cents in his pocket, a book of poetry, a letter of recommendation, and a head full of visions that would change the world. The letter was addressed to Thomas Edison. It read, "I know 2 great men. One is you, the other is this young man. Wo, Edison hired him." And immediately the 2 geniuses clashed. So as you drift deeper into this story, picture Tesla in that moment, standing in a park in Budapest, stick in hand, drawing circles in the dirt, his eyes blazing with light as he watched the invisible motor spin in his mind. The future had arrived. He just needed to convince the world to see it. Chapter 3. The War of Currents. Thomas Edison was already famous when Tesla walked into his office in 1884. Edison had invented the phonograph, improved the telegraph, and, most importantly, created the first practical incandescent light bulb. His Pearl Street power station in Lower Manhattan was lighting up homes and businesses with direct current electricity. Direct current, or DC, flows in one direction, like water through a hose. It's simple, reliable, and safe at low voltages. Edison had built his entire empire on it, but DC had a fatal flaw. It couldn't travel far. Electricity loses energy as it flows through wires. With DC, if you wanted to transmit power more than a mile or two, the voltage would drop so much that lights would dim and motors would stall. The only solution was to build power plants every few blocks. This worked in dense cities like Manhattan, but it made rural electrification impossible, and it meant Edison's system could never truly scale. Tesla knew this. He had a better solution: alternating current. AC doesn't flow in one direction. It oscillates back and forth, reversing direction dozens of times per second. This seems counterintuitive. How does a current that constantly reverses actually deliver power? The answer is transformers. With AC, you can use a transformer to step up the voltage to very high levels, tens of thousands of volts, for long-distance transmission. High voltage means low current, which means less energy lost to resistance. Then, at the destination, you step the voltage back down to safe levels for homes and businesses. You can't do this with DC. There's no easy way to change DC voltage efficiently. So AC could transmit power hundreds of miles with minimal loss. It could electrify entire regions from a single power plant. It was the future, but Edison refused to see it. When Tesla explained his AC system, Edison dismissed it. Tesla's ideas are splendid, he said, but they are utterly impractical. He offered Tesla a deal. If Tesla could improve the efficiency of Edison's DC generators, he'd pay him $50,000, an enormous sum at the time. Tesla threw himself into the work. He redesigned Edison's machines, making them faster, more efficient, more reliable. Within months he delivered. Edison was impressed. But when Tesla asked for the $50,000, Edison laughed. "Tesla, you don't understand our American humor. The money was a joke." Tesla quit on the spot. For a while he struggled. He dug ditches for $2 a day, living in flop houses, his brilliant mind reduced to manual labor. But he never stopped working on his AC system in his mind, refining it, perfecting it. Then, in 1887, he caught a break. A group of investors believed in his vision and helped him set up the Tesla Electric Company. Finally, he had a workshop where he could build the machines he'd already perfected in his imagination. He filed patents for his AC motor and his entire polyphase system, and he caught the attention of George Westinghouse, an industrialist who immediately understood what Tesla had created. Westinghouse bought the patents for $60,000 plus royalties. More importantly, he had the resources to commercialize AC power on a massive scale. This terrified Edison. If AC succeeded, Edison's entire DC infrastructure would become obsolete. His power plants, his generators, his patents, worthless. His empire would crumble, so Edison launched a campaign to destroy AC. He called it dangerous, deadly, unfit for human use. He published pamphlets showing the dangers of high-voltage AC. He hired engineers to publicly electrocute animals, dogs, cats, horses, even an elephant named Topsy, using a C current to demonstrate its lethality. He lobbied states to adopt AC for executions, hoping people would associate it with death. The electric chair was born from Edison's propaganda campaign against Tesla's technology. It was vicious, unscientific, and deeply personal. Edison, the famous inventor, the Wizard of Menlo Park, was using fear and spectacle to fight a superior technology. But Tesla didn't respond with fear or anger. He responded with light. In 1893, Westinghouse and Tesla won the contract to illuminate the world's Columbian Exposition in Chicago, a massive World's Fair celebrating the 400th anniversary of Columbus's arrival in America. The fair would showcase the future, 200,000 incandescent lamps, all powered by Tesla's alternating current. On opening night, President Grover Cleveland pressed a button. Instantly, the fairgrounds exploded with light. Buildings glowed. Fountains sparkled. The night sky turned bright as day. Over 27 million people visited the fair that summer, and every single one of them witnessed the power of AC. They saw it was safe. They saw it was beautiful. They saw it was the future. Edison's DC system never recovered. The final blow came in 1895 when Westinghouse and Tesla won the contract to build the world's first major hydroelectric power plant at Niagara Falls. The Niagara Falls Power Company chose AC to transmit electricity to Buffalo, 20 miles away. When the plant came online in 1896, it was a triumph. Tesla's childhood vision, energy flowing like water, had become reality. The war of currents was over. Tesla had won. Today, every electrical outlet in your home uses alternating current. Every power plant, every transmission line, every grid on Earth is built on Tesla's design. Edison's DC is a historical curiosity, relegated to batteries and niche applications. Tesla powered the modern world, and he did it with the technology he'd perfected in his mind years before anyone believed it was possible. So, imagine the World's Fair in 1893, a city of light appearing in the darkness, proving that dreams, when grounded in physics and mathematics, can illuminate the world. Chapter 4. The 369 Code. Nikola Tesla was obsessed with numbers, but not just any numbers, 3, 6, and 9. He believed these numbers held the key to the universe. If he was staying in a hotel, he would only accept a room if its number was divisible by 3. Room 207? Unacceptable. Room 207? No. Room 306? Perfect. Before entering any building, he would walk around it 3 times, not 2, not 4, always 3. He would use exactly 18 napkins at dinner, 3 sets of 6. He would swim exactly 27 laps in a pool, 3 times 9. To most people, this seemed like madness, obsessive-compulsive disorder, the eccentricity of a brilliant but unstable mind. But Tesla didn't think he was crazy. He believed he had discovered something fundamental about the structure of reality. If you only knew the magnificence of the 3, 6, and 9, he once wrote, then you would have the key to the universe. What did he mean? Tesla saw the universe as vibration. Everything, matter, energy, light, sound, was vibration at different frequencies, and these vibrations followed patterns, mathematical relationships that could be expressed in numbers. He noticed that the numbers 3, 6, and 9 appeared everywhere in nature. A circle has 360 degrees. 3 plus 6 plus 0 equals 9. There are 60 seconds in a minute, 60 minutes in an hour. 6 plus 0 equals 6. The Earth's axis is tilted at approximately 23.4 degrees. 2 plus 3 plus 4 equals 9. The speed of light is roughly 300,000 kilometers per second. 3 plus 0 plus 0 plus 0 plus 0 plus 0 equals 3. Musical octaves double in frequency. A note at 440 Hz becomes 880 Hz, an octave higher. 4 plus 4 plus 0 equals 8. 8 plus 8 plus 0 equals 16. 1 plus 6 equals 7. But wait, if you keep doubling through octaves, the digital root, the sum of the digits reduced to a single number, cycles through 1, 2, 4, 8, 7, 5, and repeats. Never 3, 6, or 9. Tesla believed 3, 6, and 9 were different. They weren't part of the cycle. They were the cycle's architects. In his mind, 3 represented the field, the fundamental force, 6 represented the physical manifestation, and 9 represented the completion, the return to unity, trinity, duality, singularity. Modern physics has hints of this. The standard model of particle physics organizes fundamental forces into groups. The strong nuclear force has 3 color charges. Electromagnetism and the weak force are unified in the electroweak theory. Gravity remains apart, stubbornly refusing to fit into the pattern. 3 forces, 6 quarks, 9. We're still looking for the 9th piece. Tesla also noticed patterns in alternating current. A sea oscillates in sine waves. A full cycle completes 360 degrees, reducing to 9. The phase relationships in 3-phase power, which Tesla invented, are separated by 120 degrees. 1 plus 2 plus 0 equals 3. 3-phase AC is more efficient than single-phase. It's smoother, delivers more power, and is used in virtually all industrial applications. Why? Because 3 creates a rotating magnetic field, the basis of Tesla's AC motor. 3 is the minimum number needed to create rotation. 2 phases oppose each other. 3 creates circular motion, the spiral, the vortex, the geometry of manifestation. Tesla believed that if you could understand the vibrational relationships encoded in 3, 6, and 9, you could tap into the fundamental energy of the universe. You could generate power from the vacuum itself. You could transmit energy wirelessly across the globe. You could manipulate space-time. He wasn't just being mystical. He was trying to find a pattern, a mathematical key that would unlock infinite energy. And he thought he'd found it in the Earth itself. The Earth has a natural resonant frequency, the Schumann Resonance, named after physicist Winfried Otto Schumann, who predicted it in 1952, though Tesla had discovered it decades earlier. The Schumann resonance is approximately 7.83 Hz. It's caused by electromagnetic waves trapped between the Earth's surface and the ionosphere, resonating like a bell. 7.83 Hz. The digital root? 7 plus 8 plus 3 equals 18. 1 plus 8 equals 9. Tesla believed that if you could match the Earth's resonant frequency and pump energy into it at precisely the right phase, you could create a standing wave that would circle the globe. This wave could be tapped anywhere on Earth. Free energy, wireless, infinite. This wasn't magic. It was resonance. Resonance is real. Every object has a natural frequency at which it vibrates most easily. Push it at that frequency, and even a tiny force can build up enormous energy. A child on a swing knows this. Push at the right moment, when the swing is at the top of its arc, and it goes higher and higher. Push at random times and the energy dissipates. Tesla wanted to push the Earth on its swing, and for a while he tried. At his experimental station in Colorado Springs, he built enormous Tesla coils, massive transformers that could generate millions of volts. He was pumping energy into the Earth, trying to set up resonant waves. He succeeded to an extent. He lit light bulbs wirelessly miles from his station. He created artificial lightning bolts over 100 feet long. He claimed he could detect electrical disturbances from thunderstorms thousands of miles away. But he never achieved his ultimate dream: wireless power transmission on a global scale. Why not? Some say the physics didn't work. The Earth isn't a perfect conductor. The ionosphere isn't a perfect reflector. Energy would dissipate before completing a full circuit. Others say he was sabotaged. J.P. Morgan, who funded some of Tesla's work, cut off his financing when he realized Tesla's system would make electricity free. You can't sell free electricity. Tesla believed it was possible. He spent his final years trying to prove it, obsessed with the numbers, convinced that 3, 6, and 9 were the code to unlock the universe's energy. Was he right? We don't know. Modern physics hasn't found a simple numerical key to everything. The universe is more complex than Tesla imagined. Quantum mechanics, relativity, string theory. These frameworks are beautiful, but they don't reduce to a 3-digit code. But maybe Tesla saw something we're still missing. Maybe his obsession wasn't madness, but a glimpse of a deeper pattern we haven't yet deciphered. Let the numbers rest gently in your mind. 3, 6, 9. The trinity of Tesla's universe. Whether it unlocks infinite energy, or simply reveals the mind of a genius trying to impose order on chaos, it's a beautiful dream. Chapter 5. Wardenclyffe Tower. The dream that failed. In 1901, Nikola Tesla broke ground on what he believed would be his greatest achievement, Wardenclyffe Tower. It was to be a global wireless transmission station, not just for communication, but for power. Tesla envisioned a world where anyone, anywhere on Earth, could tap into free wireless electricity. No power lines, no coal plants, no monopolies. Energy as abundant and free as sunlight. The tower would stand 187 feet tall on Long Island, New York, topped with a massive copper dome. Beneath it, Tesla would drill hundreds of feet into the Earth, creating a well to access the planet's natural electrical conductivity. The idea was simple, at least to Tesla. Pump high-frequency AC current into the Earth at its resonant frequency, creating a standing wave that would circle the globe. Receiving stations anywhere could tap into this wave and extract power. It was brilliant. It was ambitious. It was decades ahead of its time, and it required an enormous amount of money. Tesla approached J.P. Morgan, one of the wealthiest men in America. Morgan was intrigued. He'd already funded some of Tesla's experiments, including the work at Colorado Springs. Wireless communication was clearly valuable. Marconi had just sent the first transatlantic radio signal, but Tesla wasn't pitching wireless communication. He was pitching wireless power. Morgan gave him $150,000, a substantial sum but far less than Tesla needed. Tesla took it and started building, convinced he could prove the concept and secure more funding later. The tower rose. The dome gleamed in the sun. Tesla worked tirelessly, often sleeping only 2 hours a night, his mind buzzing with calculations, visions of the completed system lighting up the world. But problems arose immediately. First, the technology was complex. Even Tesla, with his mental laboratory, underestimated the engineering challenges of building at this scale. The tower's resonance had to be precisely tuned. The Earth's conductivity varied. Atmospheric conditions changed. Every variable mattered. Second, Marconi beat him to a headline. In December 1901, Marconi successfully transmitted a radio signal across the Atlantic Ocean. It was a publicity triumph. Suddenly, investors were pouring money into Marconi's company, not Tesla's. Tesla tried to explain that his system was far superior, not just communication, but power transmission. But to investors, Marconi's system was proven. Tesla's was theoretical. Third, and most devastating, J.P. Morgan learned the full scope of Tesla's vision. When Morgan asked how he'd make money from wireless power, Tesla explained, anyone with the simple receiver could tap into it. You wouldn't need to charge customers per kilowatt. Energy would be free. Morgan stared at him. Free? He asked. You're telling me that anyone anywhere could access this power without paying? Exactly, Tesla said, beaming. It democratizes energy. It ends poverty. Everyone benefits. Morgan ended the meeting. He never gave Tesla another cent. Because J.P. Morgan didn't invest in energy. He invested in control. He owned coal mines, railroads, power companies. His wealth came from monopolizing resources. Free energy threatened everything he'd built. Tesla pleaded for more funding from Morgan and others. He wrote desperate letters. He mortgaged his personal assets. He poured every dollar he had into Wardenclyffe, but the money dried up. Construction slowed, then stopped. The tower stood half-finished, a monument to an impossible dream. In 1906, Tesla was forced to shut down Wardenclyffe. He couldn't afford to complete it, couldn't afford to maintain it, couldn't even afford to keep the land. In 1917, the tower was demolished, dynamited, sold for scrap to pay Tesla's debts. He watched it fall, this giant structure that was supposed to change the world, reduced to rubble, and with it fell Tesla's dream of free, wireless energy for all humanity. Why did Wardenclyffe fail? Technically, it's unclear. Tesla never completed it, so we don't know if it would have worked. Modern physicists are skeptical. The Earth's conductivity is too low. The ionosphere isn't stable enough. Energy losses would be enormous. But some engineers think Tesla was onto something. The basic physics of resonance is sound, and recent experiments in wireless power transmission, using magnetic resonance to charge devices across rooms, show that Tesla's ideas weren't completely off base, just ahead of their time. The real reason Wardenclyffe failed, though, wasn't technical. It was economic. Tesla's vision didn't fit the capitalist model. How do you profit from free energy? How do you build an empire on something everyone can access? You don't. So the empire crushed the dream. Tesla spent the rest of his life bitter about this. He saw Wardenclyffe as the moment the world chose greed over progress. He had offered humanity liberation from energy scarcity, and humanity, or at least its wealthiest members, said no. In his later years, he would walk past the empty lot where Wardenclyffe had stood, staring at the ground where the tower's foundation once lay, imagining the world that might have been, a world where every home glowed with free light, where factories ran on wireless power, where energy was as abundant as air, where the poor and the rich had equal access to the fundamental force of civilization. It's a beautiful vision, and maybe, someday, we'll find a way to make it real. Solar panels, wind turbines, fusion reactors, all of these are steps toward abundant, cheap, democratized energy. But we're not there yet. We're still paying per kilowatt, still fighting over coal and oil, still treating energy as a commodity to be controlled rather than a human right to be shared. Tesla saw that future. He tried to build it, and the world wasn't ready. So imagine Wardenclyffe Tower at its peak, gleaming in the sun, copper dome shining, ready to light up the world. A dream made of wood and wire and mathematics. A dream that crumbled because it was too generous, too radical, too free. And ask yourself, what would the world look like if we'd let him finish it? If you're still with me in this late-night journey through Tesla's extraordinary mind, you're part of something rare. Curious souls willing to explore the dreams that light up civilization. A quick subscribe helps others find these contemplative voyages through the lives of genius. Now, let's continue deeper into Tesla's strange and brilliant world. Chapter 6. The Earthquake Machine. In 1898, Nikola Tesla nearly destroyed Manhattan with the device that fit in his pocket. He was working in his laboratory on East Houston Street, experimenting with mechanical resonance. He'd been thinking about how every object has a natural frequency, a rate of vibration at which it oscillates most easily. A wine glass, for example, has a natural frequency. If you sing or play a note at exactly that frequency, the glass will vibrate. If you sustain the note long enough, the vibrations build up until the glass shatters. This is resonance. And Tesla wondered, what if you could use it deliberately to amplify small forces into large ones? He built a small mechanical oscillator, a piston driven by compressed air or steam, designed to vibrate at adjustable frequencies. It was about 7 inches long, no bigger than an alarm clock. He attached it to a steel beam in his lab and turned it on. At first nothing happened. The oscillator hummed quietly, vibrating at a frequency that didn't match the building's natural resonance. Then Tesla began adjusting the frequency, searching for the sweet spot. Suddenly the entire building began to shake. The floor trembled, the walls vibrated, tools rattled on the workbenches, glass beakers shattered, windows cracked. Tesla, fascinated, watched as the vibrations intensified. The building was entering resonance. Every pulse of his tiny oscillator was adding energy to the structure, and the structure was amplifying it. He later described the sensation. I could feel the beam trembling. It was in resonance with my machine. Outside, people panicked. Buildings across the neighborhood were shaking. Residents thought it was an earthquake. Some ran into the streets, others called the police. Inside his lab, Tesla realized what was happening. The vibrations had spread from his building to the bedrock beneath Manhattan, and from there to neighboring structures. He was accidentally exciting the entire city's resonant frequency. If he let it continue, the oscillations would build until something catastrophic happened. A building might collapse, gas lines might rupture, the damage could be enormous. Tesla grabbed a sledgehammer and smashed the oscillator to pieces. Instantly the shaking stopped. Moments later, the police arrived, demanding to know what had caused the earthquake. Tesla, ever the showman, smiled and said, "Gentlemen, I am sorry. You're just a trifle too late to witness my experiment. I found it necessary to stop it suddenly and unexpectedly in an unusual way. If you want to know what I was doing, I was vibrating the building and everything around it, with a little machine no bigger than this." He held up the broken oscillator. The police were baffled. How could something so small cause such destruction? Tesla explained the principle of mechanical resonance. "Give me a long enough lever and a place to stand," he said, paraphrasing Archimedes, "and I can move the earth. But give me the right frequency and I can destroy it." He wasn't exaggerating. In principle, if you could find the Earth's natural resonant frequency and apply even a small force at that frequency for long enough, you could set up oscillations large enough to cause earthquakes, split continents, shatter the planet itself. Tesla claimed that with a refined version of his oscillator, he could split the Earth in two like an apple. Again, this sounds like madness, but the physics is real. Resonance is incredibly powerful. It's how opera singers shatter wine glasses. It's how bridges collapse in high winds. The Tacoma Narrows Bridge in 1940 failed because wind created oscillations at the bridge's resonant frequency, and the structure tore itself apart. It's how earthquakes propagate. Seismic waves resonate through the Earth's crust, amplifying as they travel. Tesla understood this better than almost anyone. He'd seen how alternating current could create rotating magnetic fields through resonance. He'd seen how wireless transmission relied on tuning transmitter and receiver to the same frequency. And now he'd seen how a tiny machine, properly tuned, could shake an entire city. He never built a larger version. He was too afraid of what it might do. But he kept the plans, and he hinted at its potential in his writings. Imagine, he said, a fleet of oscillators placed at strategic points around a fault line. Tune them all to the fault's resonant frequency. Turn them on. Wait. Within hours, the accumulated vibrations would trigger an earthquake. Not a random earthquake, but a precisely timed, controlled release of seismic energy. He called it telegeodynamics, remote earth-shaking. It was never built. But during World War II, both the Allies and the Axis reportedly investigated resonance weapons based on Tesla's ideas. The US military even considered using resonance devices to collapse enemy bunkers or destroy infrastructure. None of these weapons were ever deployed, at least not publicly. But the principle remains sound. With the right frequency and enough time, even a tiny force can create catastrophic effects. Tesla's earthquake machine is a reminder of how powerful resonance is and how dangerous. It's also a reminder of Tesla's genius. He saw connections others missed. He understood that energy, matter, structure, everything vibrates. And if you match the vibration, you control the system. Whether it's a motor, a power grid, a building, or the Earth itself, the principle is the same. Find the frequency, match the phase, and the universe resonates with you. So as you rest in this knowledge, imagine Tesla in his lab, holding a device small enough to fit in his coat pocket, feeling the building shake beneath him, knowing he'd found the resonant heartbeat of the city, and choosing wisely to stop. Because some powers, once unleashed, are too dangerous to control. Chapter 7. The Ether and Infinite Energy. Nikola Tesla didn't believe in empty space. To him, the vacuum of space wasn't a void. It was a primary medium, an invisible energetic substance that filled all of reality. He called it the ether. This wasn't mysticism. It was physics, or at least it was the physics of Tesla's time. In the 19th century, most physicists believed in the ether. Light was understood to be a wave, and waves need a medium to travel through. Sound waves travel through air. Water waves travel through water. So what does light travel through? The answer, scientists thought, must be an invisible, all-pervading substance, the ether. James Clerk Maxwell, whose equations unified electricity and magnetism, believed in the ether. So did Heinrich Hertz, who discovered radio waves. The ether was the foundation of classical electromagnetism. But in 1887, Albert Michelson and Edward Morley conducted an experiment to detect the ether by measuring how Earth's motion through it would affect the speed of light. They expected to find a wind as Earth moved through the ether, just as you feel wind when you stick your hand out of the moving car. They found nothing. No wind, no variation in light speed, no ether. This result baffled physicists. If light is a wave, and there's no medium for it to wave in, what's going on? Albert Einstein provided the answer in 1905 with his theory of special relativity. Light doesn't need a medium. It's an electromagnetic wave, and electromagnetic fields can oscillate on their own without requiring a physical substance to carry them. Space is truly empty, or at least it contains fields, not matter. The ether was declared dead. Physics moved on. But Tesla never accepted this. To him, Einstein's relativity was a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. Tesla insisted that space couldn't be empty. How could energy propagate through nothing? How could fields exist without a medium to sustain them? He clung to his belief in the ether, but with a twist. He didn't think of it as a static substance. He thought of it as a dynamic, energetic medium, a kind of superfine gas denser than anything we can measure, pervading all space, vibrating at incredibly high frequencies. This primary medium, Tesla believed, was the source of all energy. If you could tap into its vibrations, you could extract limitless power. How? Tesla proposed that the ether was in constant motion, like a turbulent fluid. Atoms, electrons, even light were simply disturbances in this fluid, vortices, waves, patterns of motion. By creating the right kind of disturbance, a resonance, a standing wave, you could extract energy from the ether itself. You wouldn't need fuel. You wouldn't need a power plant. The energy was already there, everywhere, infinite and free. He called this radiant energy, or cosmic energy. At Colorado Springs, he claimed to have detected this energy. Pulses of electricity that seemed to come from nowhere, oscillations in the Earth's electrical field that didn't correspond to lightning or any known source. He believed he was tapping into the ether's vibrations. Modern physics doesn't support this. Quantum field theory shows that space isn't empty. It's filled with quantum fields, and these fields have zero-point energy, a minimum energy level even in a vacuum. But you can't extract this zero-point energy, at least not easily. It's not like a battery you can tap into. The energy is locked in fluctuations that cancel out on average. So Tesla's dream of infinite energy from the ether remains unrealized. But here's the intriguing part: Tesla wasn't entirely wrong. Quantum mechanics does suggest that the vacuum is seething with activity. Virtual particles pop in and out of existence. Quantum fields oscillate. There is energy there. The Casimir effect, discovered in 1948, proves this. If you place two metal plates very close together in a vacuum, they experience a tiny attractive force. Why? Because the vacuum between the plates contains fewer quantum fluctuations than the vacuum outside, creating a pressure difference. Energy from the vacuum, not infinite, not free, but real. Tesla would have loved this. He would have seen it as vindication. Empty space isn't empty. It's full of energy, just like he said. Whether we'll ever learn to tap this energy on a useful scale is an open question. Some physicists think it's possible. Most think it's impractical. But the idea lingers that space itself is a reservoir of energy, waiting to be unlocked. Tesla spent his later years working on this problem. He designed bizarre apparatus, strange coils, unusual geometries, devices he claimed could resonate with the ether's vibrations. None of them worked, at least not in the way he hoped. But he never gave up. Even in his 80s, living in poverty in a New York hotel, he insisted he was close to a breakthrough. He claimed he'd discovered a new form of energy, a new way to transmit power, a new understanding of the cosmos. He died before he could prove it. Were his ideas about the ether correct? No, not in the way he imagined. But were they pointing towards something real? Maybe. Quantum field theory, vacuum energy, zero-point fluctuations. These are all echoes of Tesla's intuition that space is not nothing, but something. A something we don't yet fully understand. So just as you drift deeper into this contemplation, imagine the universe as Tesla saw it. Not empty, but full. Not silent, but humming with vibrations. Not barren, but alive with energy, waiting for the right frequency, the right resonance to set it free. Whether that energy will ever power our world, we don't yet know, but the dream is beautiful. Chapter 8. The Eccentric Genius, Nikola Tesla never married. He never had children. He never had a romantic relationship of any kind, as far as historians can tell. He said he couldn't afford the distraction. I do not think there is any thrill that can go through the human heart like that felt by the inventor as he sees some creation of the brain unfolding to success, he wrote. Such emotions make a man forget food, sleep, friends, love, everything. Instead, Tesla had peculiarities, obsessions, habits so rigid they defined his daily life. He was terrified of germs. He would use a new stack of napkins at every meal, exactly 18, arranged in 3 sets of 6, and would never shake hands unless absolutely necessary. He couldn't stand the sight of pearls. If a woman wearing pearls approached him, he would refuse to speak to her. No one knows why. It was visceral, irrational, absolute. He was obsessed with the number 3, as we've discussed. But it went beyond buildings and hotel rooms. He would count his steps when walking, ensuring the total was divisible by 3. If he miscounted and ended on the wrong number, he would circle back and start again. He slept, by his own account, only 2 hours per night. This wasn't insomnia. It was discipline. He believed excessive sleep dulled the mind. Instead, he would enter what he called the state of deep contemplation. He would lie in darkness, completely still, and his mind would ignite. He described it as almost hallucinatory. His eyes, even closed, would flash with light. He would see his inventions appear before him, glowing, rotating, fully 3-dimensional. Friends who visited him late at night reported seeing him lying on his bed, eyes open but unseeing, staring at something invisible, his pupils dilated, his breathing shallow. He was in the mental laboratory, building, testing, perfecting. When he emerged from these states, he would work furiously, translating the visions into sketches, notes, patents. He claimed that some of his best inventions came from these 2-hour sessions, not from days of waking effort. Modern neuroscience might classify this as a hypnagogic state, the borderline between waking and sleeping, where the brain produces vivid imagery and creative insights. Tesla had mastered it, turned it into a tool. But it came at a cost. He was exhausted. His health deteriorated. He suffered nervous breakdowns, periods where the visions overwhelmed him, and he couldn't distinguish imagination from reality. And then there was the pigeon. In his later years, living alone in a New York hotel, Tesla befriended the pigeons in Bryant Park. He would feed them, talk to them, give them names. But one pigeon was special. She was white, with light grey tips on her wings. Tesla described her as beautiful and intelligent. He said she would fly to his window every evening, and he would let her inside. She would perch on his desk while he worked, and he would feed her, stroke her feathers, talk to her. He fell in love with her. Not metaphorically. Tesla, in his own words, said, "I loved that pigeon as a man loves a woman, and she loved me." When the pigeon became sick, Tesla nursed her. He spent thousands of dollars on veterinary care trying to save her. One night, she flew to his window, and he knew immediately something was wrong. She looked at him, he said, and a brilliant light shone from her eyes, a light so intense it illuminated the room. Then she died in his arms. Tesla was devastated. He later said, "When that pigeon died, something went out of my life. I knew my life's work was finished. This sounds like madness." And maybe it was. Tesla by this point was old, alone, impoverished, and his mind, once so precise, so capable of visualizing the impossible, was fraying. But there's another way to understand it. Tesla had sacrificed everything for his work. He'd given up love, family, comfort, wealth. He'd lived in his imagination more than in the world, and in his final years, isolated and forgotten, he found companionship in a pigeon. It's tragic, but it's also deeply human. He died on January 7th, 1943, alone in room 3327 of the New Yorker Hotel. Note the room number: 3 + 3 + 2 + 7 = 15. 1 + 5 = 6, divisible by 3. The maid found him the next day. He was 86 years old. His funeral was attended by over 2,000 people, scientists, engineers, dignitaries. But few of them had known him personally. They came to honor the inventor, the genius, the man who had lit up the world. But who was Tesla, really? A man who saw too much. A man who lived in his mind more than his body. A man who loved a pigeon because he'd never let himself love a person. A man who glimpsed the future and spent his life trying to drag it into the present, only to watch it slip through his fingers. He was brilliant. He was strange. He was lonely. And he was, perhaps, the most important inventor in human history. As you rest with this image, imagine Tesla in his final years, white-haired, gaunt, feeding pigeons in the park, counting his steps, walking in patterns only he understood, still dreaming of wireless power, still seeing visions of machines that might save the world. A genius, an eccentric, a dreamer, alone, but never quite alone. Because in his mind, the inventions were still real, still glowing, still turning. Chapter 9. The Forgotten Inventor. When Nikola Tesla died in 1943, the world barely noticed. The New York Times ran an obituary. A few newspapers mentioned it. But there was no outpouring of grief, no national day of mourning, no recognition that one of history's greatest minds had just gone dark. He died broke. His hotel room was filled with papers, notebooks, sketches, theories, but no money. The hotel claimed his belongings to settle unpaid bills. The FBI, concerned that Tesla's papers might contain sensitive information, he had been working on a death ray and other weapons, seized everything and classified it. Most of his work has since been released, but some remains locked away, deemed too dangerous or too incomplete to share. For decades, Tesla was forgotten. Textbooks mentioned him briefly, if at all, as a footnote to Edison or Marconi. His contributions were downplayed, dismissed, or attributed to others. Why? Partly it was timing. He died during World War II when the world had bigger concerns. But also, his life didn't fit the narrative people wanted. Edison was the self-made man, the hard worker who succeeded through persistence, a capitalist hero. Tesla was the eccentric loner, the man who gave his inventions away, who died penniless despite powering the world. He didn't fit the success story America wanted to tell, but slowly Tesla's reputation has been rehabilitated. In the 1980s and 1990s, engineers and historians began re-examining his work. They realized how foundational his contributions were. Alternating current, the induction motor, radio transmission, wireless communication, remote control, X-ray imaging, neon lighting, robotics, all of these trace back to Tesla. Today, his name is everywhere. Tesla Motors, the electric car company, is named after him. The unit of magnetic flux density is the Tesla. Statues of him stand in New York, Belgrade, and Niagara Falls. He's become a folk hero, especially among engineers and inventors who see in him a kindred spirit, someone who valued ideas over profit, who dreamed bigger than the market allowed. But here's the uncomfortable truth. Tesla's vision failed. He didn't give us wireless power. He didn't free energy from corporate control. He He didn't create the world he imagined. Instead, we live in Edison's world. Energy is metered, controlled, sold. Power lines crisscross the globe. Corporations own the infrastructure. We pay per kilowatt. Tesla dreamed of liberation. We got capitalism. Does that make him a failure? Not exactly. Yes, Wardenclyffe fell. Yes, his wireless power system was never built. Yes, he died alone and broke. But his AC motor powers every industrial machine on Earth. His polyphase system delivers electricity to every home. His understanding of resonance enabled radio, television, and wireless communication. The modern world runs on Tesla's inventions. He just didn't get to see it reach its full potential. And he didn't get to live in the world he wanted to create. A world where energy was free, where technology served humanity, where the genius of invention wasn't constrained by the greed of capital. We're still not there, but maybe someday we will be. Solar panels and wind turbines are making energy cheaper and more democratic. Battery technology is improving. Wireless charging is becoming common for phones and cars. Slowly, incrementally, we're moving toward Tesla's vision. Not through one grand breakthrough, but through 1,000 small steps. And that's fitting in a way. Tesla was a man of grand visions. But the world changes slowly, stubbornly, resisting revolution even as it benefits from it. So what's Tesla's legacy? It's the light in your house, the motor in your appliances, the signal in your phone, the hum of the electrical grid that powers civilization. It's the dream that energy could be free, abundant, democratic. A dream we haven't achieved but haven't abandoned. It's the reminder that some minds see farther than their time allows. That genius can be lonely, unrewarded, forgotten, and still change the world. Tesla didn't die a hero, but history has slowly, reluctantly made him one. And maybe that's the best we can hope for. To plant seeds we won't live to see bloom. To dream dreams we won't see realized. To light a path for others to follow, even if we walk it alone. Tesla lit the world, and though he died in darkness, his light still shines. So as you drift into rest, imagine Tesla one last time. Not the old man in the hotel room, but the young inventor in Colorado Springs, watching lightning arc across his laboratory, his eyes blazing with light, his mind full of visions, believing, truly believing, that he could give the world infinite energy. He couldn't, but he gave us enough to keep dreaming. And maybe that's the real power of genius, not what it achieves, but what it inspires. And so, as we step back from the mind of Nikola Tesla, we're left with a question that has no simple answer. Can you power the world with a dream? Tesla believed you could. He saw energy as infinite, accessible, free. He saw technology as liberation, not exploitation. He saw the future, and he tried to build it with copper coils and mathematical precision. He failed in many ways, but he also succeeded beyond measure. Because every time you flip a switch, you're using his invention. Every time wireless signals carry information through the air, you're benefiting from his insight. Every motor, every grid, every piece of electrical infrastructure. It's Tesla's dream, made real. If this journey through the life of a forgotten genius has sparked wonder in you, consider subscribing to Sleep Entangled for more explorations of the minds that shaped our world. And as you rest tonight, let Tesla's visions float gently through your thoughts. Cities of light, wireless energy, infinite possibilities. This is Sleep Entangled, where the dreams of genius become the light we live by. Rest well, knowing that some dreams, though incomplete, illuminate the future,